Hello, this is Mr. Novak. Today we're going to be working on work. So we're going to take some notes on work. So with this presentation on notes, we'll kind of get into kind of the application of work, of real life examples, as well as kind of the mathematical or math-oriented application of it as well. So let's take a look here. So our first part here is work is a force exerted on an object that causes it to move. Work is done on an object when the object moves in the same direction in which the force is exerted, and an object must move some distance because of a force for it to be called work. So pretty much what that is telling us, when we're doing work, there needs to be a force and there needs to be a distance moved. Okay, so the force and distance will usually be working in that same direction, but it also lets you know that if there's not one of those available, if you don't have a distance, if it doesn't travel a distance, then it wouldn't be work, and that's an important thing to note. Okay, our formula for work is work equals force times distance, or it will be represented as W equals F times D, and the unit for work is joules, and that can be labeled with a J. So it's very important to kind of note that joules will be the unit that we'll use, and this will be something as we move into our next unit, we're going to be talking about energy, and that's also the label or unit that will be used for energy would be joules as well. So kind of some practical examples to see of what what's examples of work and what's not work. So our first one, if you look to the one on our left here, is lifting a book. So what we need when we're trying to calculate work, we need to know what the work, what the force is, as well as the distance is. So if we look at this book, as it comes back down, we notice that the book's weight or force would be 10 newtons. Okay, and we also note, so that would be our force, and we also notice right here, this goes a distance of 1 meter. So if we have a force and we have a distance, that tells us that there is work. So it does travel a distance, it would be work. Now let's take a look at holding a book. Okay, kid has the book in his hand. This is an example of not work. So let's say the book is still 10 newtons. Let's just say, but is the book moving at all? It is not, right? So our distance would be 0. Okay? So if it doesn't have a distance, it means it's not working. Okay? Because you need to have both. You need to have a force and you need to have a distance in order for it to be work. Okay, so we have a couple math problems here for us to kind of look at. So our formula again up here is work equals F times D, which is force times a distance. So let's read the problem. So Bill is picking up a plant that is 50 newtons. The distance or height that it is traveling is 2 meters. What is the amount of work that Bill is doing? So our first thing, what we want to do is we want to identify our numbers in here. So we see 50 newtons, and we also see 2 meters. So my F would be 50 newtons. My D would be 2 meters. And my formula, again, we look up top here, would be W equals F times D. So it would be 50, W equals 50 times 2. So my work would be 100, and our unit would be joules. So 100 J, right? 100 joules. Okay. And let's take a look at our last problem here. Ashley is pushing a table across the room with a force of 60 newtons. The table travels a distance of 5 meters. What is the amount of work Ashley is doing? So again, we're going to identify our numbers in the problem. So we have 60 newtons, force of 60 newtons, and we also have a distance of 5 meters. So our F would be 60 newtons. Our D would be 5 meters. Okay. Our formula again, right, up here, let's take a look, is work is equal to force times distance. So our force would be 60 newtons times 5. Okay, so 60 times 5. So our W would equal 300 joules. Right, so that's again just a kind of reminder of our label. As we do these kinds of problems, it's important to kind of note, just remember why you would need force. You need to have a force as well as a distance. If it doesn't have those two things, then it would not be work. If you have any questions, please let me know. Once again, this is Mr. Novak, and I am signing off.